Hello everyone. Today let us talk about logistic regression. So logistic regression is again supervised learning algorithms. So till now, whatever algorithms that we are studying or we have seen, all of them are supervised learning algorithms. Right now, we have not touched any of the unsupervised learning algorithms, and it is so the name is regression, but we mostly use it for classification. So this is the word that we need to highlight here, that is it is mostly used for classification problem. So the name is regression, but we mostly use it for classification problem. It predicts the probability. So again, it is a probabilistic algorithm like naive Bayes algorithm, but the difference is in naive Bayes algorithm we use Bayes theorem, whereas here we don't use any Bayes theorem or something. Here the most important thing or the most important concept, that is sigmoid function. We use the sigmoid function to find out the probabilities. So every algorithm, so even if it is, let us say, just a KNN algorithm, or let us say it is any like naive Bayes algorithm, SVM algorithm, KNN, the most important concept in KNN algorithm is the value of K, and that is the unique concept or the fundamental working of that algorithm. Then we have SVM. In SVM, we have very important one thing, that is margin, and then naive Bayes theorem. So every single algorithm that we are discussing, all of them have something unique in them. So here in logistic regression we have sigmoid function as the common function. So the first thing is that it will find out the probability, and it will always give answer in form of 0 or 1. 1 means that, let us say, if we are considering pass or fail, so if it is the answer is 1, we can say that it is pass, and if the answer is 0, we say that it is fail. So basically first we find out the probability, and then we try to compare it with 0.5. If the value of the result or whatever the resultant thing or the result that we have, if that is greater than 0.5, then we say that it is a positive result. That is, let us say, if it is spam or not spam, we can say that it is spam or something. Yes or no, it will be yes if the probability. So we set a threshold to 0.5. So if we are considering a pass or fail condition, then if the value is greater than 0.5, then we say that it is the student, he or she is passed. Otherwise we say if the probability is less than zero point 0.5, then we say that it is a fail. So basically this is how it works. It is again probabilistic algorithm. Then we have, let us say, let us see an example and let us try to understand how logistic regression works. So in this case we have number of hours studied. So there is a student who studies for 1 hour and he or she is fail in the exam. The same goes with the person. So if a student studies in between 1 to 3 hours, always the student is fail. And if the student studies for 4 hours and more, then we can say that the student is pass. So now we have a question. So let us say a student studies for some 4.5 hours. A new data point is 4.5 hours. So for 4.5 hours, what do you think? Will the student pass or will the student fail? Then this is what we need to find out. And again, it is a classification problem. So we will first try to find out the probability using sigmoid function. So the probability is always in between 0 and 1. So now, right now, like we have discussed a lot of algorithms, and just by looking at the data set we can say that now if the student pass at 4, so obviously at 4.5 it is in between 4 and 5. So we can say just by looking at the data set that the student will pass. But let us say somebody don't know at all how exactly anything works, or he or she don't know any of these algorithms. So basically we will try to calculate the probability by using sigmoid function. If that probability is greater than 0.5, then we say that the student is pass, and in this case it will be obviously greater than 0.5. And if it is less than 0.5, then we will directly say that it is the student will not pass. Then yeah, so this is what we have, that everything depends on the sigmoid function. So this is a very important function, sigmoid function, to find the probabilities. We use a sigmoid function as I said earlier, and then if we have answer greater than 0.5, then we say that he or she is pass, otherwise the student will fail. So this is how basically logistic regression work. Again, it is a probabilistic algorithm and like naive Bayes, but there we use Bayes theorem, whereas here we use sigmoid functions. So now we have the working steps. So this is something that is common for every single, I would say, for every single algorithm. This is the first step, that we collect the data and we train the model. These are the common steps. Where then we have, so there is not much working steps, only 5 or 6. That is, here the most important step is we apply a sigmoid function, and at last we compare it with the threshold. So basically when we have more specifically, we can say that when we just have two classes, at that time we should prefer logistic regression, because here we have one threshold 0.5, and if it is greater than 0.5, then we say that it is, then we can say that the student is pass or student is fail. So when we have only two classes, at that time we can prefer logistic regression. Then, like, every single algorithm has its own assumptions. In KNN algorithm also has its own assumptions. uh, Logistic regression also have its own assumptions. So the first one is binary dependent variable. Binary means two. So as I mentioned just a minute ago, that when we simply have two classes, at that time this will give us the best result. So it assumes that the variables, they are binary dependent. That means there are only two input values on which we are working. Then the observations are independent, like linear regression. Linear regression also have this independent observation assumption. The same goes with logistic regression as well. Then we have, when we have no significant outliers, this is what we assume. So logistic regression, we can say it works best when we have, when our dataset do not have any outliers. In that case we can say that logistic regression works well. So we can say that we don't have any significant outliers. In these three conditions, logistic regression can work well. Then we have advantages and the disadvantages of the same. So we can say that logistic regression is very simple, just two classes, find out the probability using sigmoid function. If it is greater than 0.5, then we can say that it is a positive result, whereas it is a negative result. So we can say that it is very simple and easy to implement, efficient for binary classifications. When, as I mentioned, when we simply have two classes, at that time we can say it is very useful or it is very efficient. And then we have uh, fast training. As we just have two classes, the training period is quite fast, and generally overfitting don't occur in logistic regression. Then we have disadvantages. Disadvantages is it works best with linear relationships, and in real world there may or may not be a condition where the data set is always linear, or the relationship in between the data set is linear. It almost never happens. It is not suitable for complex relations. So when we have a very simple problem where we just have two classes and where we need to perform classification, and where there are no outliers present, or like almost no outlier is present there, in those cases we can say that we can prefer sigmoid function, we can prefer logistic regressions. So these are the disadvantages, because in real world there are hardly few data sets available where we won't have any outliers. In real world application, everywhere we can say that outliers are present. So logistic regression, we can perform it when we have a very simple data set and very simple problem to solve. So that's all for this video. In our next video, we will be talking about regularization and its two methods. So see you in next video. That's all for this video. Thank you.